If a right cylinder has a height that remains twice its radius and the volume is decreasing at the rate of 24 pi feet cubed per hour, at the instant that the radius is 2 feet, find the rate at which the A, radius changes, B, height changes, C, surface area changes. Let's start by writing down the information that we are given here. We have, first of all, that the height remains twice the radius, so h is equal to 2r. We also have that the volume is decreasing, so the rate of change of the volume v prime, or dv dt, since it's changing with time, it's decreasing, which will make it a negative 24 pi feet cubed per hour. And we were also given the radius is equal to 2 feet. For part A, we want to find the rate at which the radius changes. We have the rate at which the volume changes, so we will need to relate the volume to the radius. For a cylinder, the volume is pi r squared times h. We do have the condition, though, that h is equal to 2r here, so we can now write the volume as pi r squared times 2r. And let's simplify that by bringing the 2 out front, so 2 and then pi, and then r squared times r becomes r cubed. There's our related variables formula. To find the related rates formula, we take the time derivative of both sides, indicated by a prime on both sides. Every variable is implicit with a time derivative, so every variable will get a prime when we take its derivative. On the left side, the derivative of v is 1, but then times v prime due to the chain rule. On the right side, we have the 2 pi is a constant, a power rule. We'll bring down the 3, multiply it with the 2 pi, that'll give us 6 pi. Subtract 1 from the power, but then multiply by the derivative of the inside to complete the chain rule. That'll give us the r prime. We will end up with a prime on every variable, because every variable is implicit with time. We can now plug our numbers in. We have that v prime is a negative 24 pi, and that equals to 6 pi times 2 squared times r prime. So negative 24 pi equals to 6 pi times 4 times r prime. Negative 24 pi equals to 6 times 4 is a 24 pi. And now we can solve for r prime by dividing negative 24 pi by 24 pi. They cancel out to become negative 1, so r prime, or dr dt, is equal to negative 1, and it'll have units of radius measured in length. Length here is feet, over time measured here as hours. For part B, we want to find how the height changes. In order to do that, we need to have a relation of height to either the volume or the radius. And we actually have a simple relation between the height and the radius, because we know the rates for the volume and the radius, so we would want to relate the height to one of those two that we know a rate for. But the simplest is going to be the height is just twice the radius. There's the related variables equation. We can find the related rates equation by taking the time derivative of both sides. The derivative of h is 1, but then times h prime. On the right side, the derivative of 2r is 2, but then times r prime, since every variable is implicit with time, and every variable would get a prime. We just found out what r prime was, so h prime is going to be 2 times the negative 1, or negative 2. And therefore, h prime, or dh dt, will be negative 2 units of height, which will be measured in length units of feet, over time, which is hours here. For part C, we want to find how the surface area changes. The surface area of a cylinder is made up of its curved side, which has a height of h and a length of the circumference of the circle. So that will be a circumference times a height. That'll be the curved wall of the cylinder. And then we also have the two end caps, the two circles. Each of them will have a pi r squared because there's two of them, 2 times pi r squared. And there's the surface area for a cylinder. We can now replace h with 2r since we have that relation here. So 2 pi r times 2r plus 2 pi r squared will give us, for the first term we can multiply the 2's. That'll give us 4. We have the pi, and then we have an r times another r squared plus 2 pi r squared. And these can now combine together. So our surface is 6 pi r squared. There's our related variables equation. We can find the related rates equation by taking the time derivative of both sides, indicated by a prime on both sides. Every variable is implicit with time, so the derivative of the left will be 1, but then times s prime. The derivative of the right will start as a power rule, bring down the 2, multiply it with the 6 pi to give us 12 pi, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. We can now plug our numbers in, so that s prime will become 12 pi times r, which is a 2, times r prime, which we found in part A to be a negative 1. These will multiply. 12 times 2 is 24, times the negative 1 is negative 24 pi. So s prime, or ds dt, will be negative 24 pi units of surface area. Area is always in units of length squared. We have length in this problem is feet squared per time. Time in this problem is in hours. So s prime will be negative 24 pi feet squared per hour.